Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan, from the Simple Electronics YouTube channel. And today's episode is sponsored by viewers like you. So head on over to patreon.com/simpleelectronics if you want to support the show. All right, let's get started. Very first thing I want to say is that I am still a little sick. You might be able to hear it on my voice, but I'm feeling a lot better. It's just that my sickness has developed into just a cough. And so this episode might be highly edited because of that. So if you hear some awkward cuts, it's because I had to look away and cough. And that's also why I don't have a guest on today, because I don't want to put them through that, right? I don't want to, cut them off while they talk because I'm having a coughing fit or whatever. So I kind of have to do things at my own pace. So here I am. Let's get started then. So, very first thing is that I am live streaming again. So I'm feeling better and able to live stream. And on the most recent live stream, which was a few days ago as of this recording, I took a look at a brand new multimeter. I don't think its release is brand new, but it is fairly new. So this is the Kaiweets HT118E, which I have dubbed the older brother of one of my favorite multimeters, the Kaiweets HT118A. It's essentially an identical multimeter, so it has a reasonable size, reasonable hand feel. Everything kind of works really well. However, the HT118A is a 6,000 count handheld multimeter, and the HT118E is a 20,000 count handheld multimeter. I actually nearly bought one for myself because my father needed a multimeter. His multimeter is kind of like those old like Harbor Freight equivalent, but like tiny little things that barely have one number after the decimal. It's extremely cheap. He said he wanted a new multimeter, so I decided to buy him one. But I ended up buying him a clamp multimeter because after talking with him for a little while, it seemed like he really preferred a clamp multimeter, so that's what I got him. But my choices essentially was the HT118A, the HT118E, because I love both those multimeters, and there was a couple other contenders. So I almost bought the HT118E, but I ended up not. And then Kaiweets reached out to me. They said they wanted to send me the 118A, and I was like, oh, I already have it. Thanks. I love it. I use it all the time. Here's the video I made on it. And they said, okay, would you like the 118E? And I said, sure, absolutely. Just send it over. I'll take a look. As long as it's not a smart multimeter, I'm not really a fan of the smart multimeters. That's the ones that only really have 2 lead spots. And then you just have it in auto. Most of them don't have a dial. They just have like push buttons and a full glass front, a little bit like a smartphone. And then you just, touch it on whatever, and then the multimeter decides if you wanted resistance or voltage or what have you. I'm not a fan of those multimeters, so I told them that if they sent me one of those, I would look at it, but I'm not a fan, so it probably wouldn't be a glowing review. But they said, that's fine. They'll send the 118E, and they said, they're sure I was going to like it. So I took a look at it. Now I am I'm talking to you about this because I'm refining my multimeter testing process. So last year I was lucky enough that Unity sent me, the UT8805E, which is a 5.5 digit, 200,000 count multimeter. I think it's 200,000 counts. I'd have to double check that. And so now, as part of my testing process, I went and grabbed my Kaiweets multimeter gauntlet, which I still use, which is essentially, I think it's 6 precision resistors, a precision voltage source, a couple of precision caps, and then I combine the voltage source with the precision resistors to get small currents. And so I went through, and at the current temperature, it's winter now, so about 18 degrees C in my workshop here in the basement, and I retested all of my standards. So I tested all of the resistors, all of the voltage standards. I tested all of the current standards with the 8805 multimeter, 5.5 digit Unity. And also, so that will be for all multimeters going forwards. I'll retest and post the results. And on top of that, since this is the 118E, which is the big brother of the A, I also went back and retested all the values on the A. So when you see the video, which is now available to my Patreon patrons, and should be available sometime this weekend publicly, you'll be able to see what the current measurements are on the Unity and what the what the measurements are with the 118A and the 118E, and I also added in the specs for whatever we're measuring. So I'm happy to report that absolutely everything is within spec. In fact, it's way better than spec. Some of the specs, like for the voltage, was plus or minus 0.8%, and then they have like something like 5 counts or 4 counts or 3 counts or whatever it is. And if you ignore the percentage, it still fell within spec. So it just varied a couple of counts up and down. And also the Unity was able to confirm to me that my precision resistors are also within spec. Everything is within spec. So the video will be a little bit more of a data dump than you would expect from my traditional videos. And that's sort of what I want to do going forward, is allow the viewer to get as much information as humanly possible, possibly more information than most people need. But the important thing here is that we have all the information for those who want it. I should also be able to convert this into into an article pretty easily, because I'll just do the testing. The testing could be images and then just transfer it to text. I'm pretty good at doing that, usually when I'm listening to podcasts. And then I can post it on my website, so you'll have those dual sources. Also, what's nice when Kai Weitz sends you something for review is they offer a discount to your viewers. So I think mine is discount code SE15. So you just go kaiweitz.com into the shop, and whatever you buy, you get 15% off, which is great because a lot of the stuff that they offer on their website's already on sale. And as far as I know, it compounds. So it adds a 15% off on top of that as well. So yeah, had a lot of fun with that. Only thing that I've noticed is that the capacitance is really not a very precise measurement. I think it was like something like 4% plus minus a bunch of counts. Hold on, I got the sheet right beside me here that I used for my testing. So capacitance is plus minus 4% plus 50 counts. So that is a lot of variation there in that. But that's weird because the HT118E has that, but the capacitance on the A is plus minus 4%, but plus 3 counts, not 50 counts. So it's a little bit weird. I always found that capacitance measurements, unless you have an LCR meter, it was a little bit all over the place. I don't know if it's just very hard to do the measurements in a reasonable amount of time without, having a frequency pulse going through. But either way, multimeter is really good. The only thing I can't say, and why I don't feel comfortable calling it a review, I always call it a first look, is I don't know about the durability. So I've been using the HT118A for years now. In fact, I could probably look up when the original video came out, and I was using it a little bit before that as well. But I can't say if it's going to last for a very long time, because even though I've been using it for years, it doesn't really leave my workbench here, right? It doesn't do. Oh my God, I've been using the HT118A since 2020, so 5 years. But yeah, it doesn't leave my workbench. So it's climate controlled. It's not a rough use, rough service life or anything. So I'm probably going to end up taking the HT118A with me to work and see if I can use it as an automotive multimeter and beat the crap out of it. Because honestly, even if I would have bought it, Kai Weitz just sent it to me, I think I would have gotten my money's worth beyond that by now. It's actually an interesting story. I'm not sure if I told it on the podcast, how I got the Kai Weitz multimeter, the first one, the HT118A. Oh, I even called it a review. Oh, that's not good. Maybe I should change that. But basically, I was getting about an email a week from multimeter companies wanting to send me their multimeters, and all of them looked, like the typical Chinesium toy, with the big rubber overmolding that make them look like transformers. They all had like very similar specs. They were all like, regular schmegular stuff you would find on AliExpress or Amazon. And I had never heard of Kaiweets at the time. And I said, you know what, I decided to answer them. I said, what makes your multimeter so special? And they said, well, it's really precise, it's calibrated, it works really well, blah, 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 all this stuff. So I said, okay, here's the deal. You can send me your multimeter. I'll take a look at it. No problem. However, you say that it's a precise multimeter. And so if I've priced out the parts I needed to make a reference, like a multimeter reference standard. So precision resistors, precision voltage reference, all that stuff. Then it came up to about $200 or something with the case and everything, and all bought from a reputable supplier like Mouser. So I said, okay, so I'll take your multimeter. I'll take a look at it, even though I have been saying no to most multimeters. But here's what I want to do. To set yours aside, if you believe in your product, I need $200, and I will build a precision reference box. And if your multimeter is as good as you say it is, then it'll do really well. And this multimeter box, this multimeter tester that I'll build, I will call it the Kaiweets Multimeter Gauntlet. And every time I use it, I will call it the Kaiweets Multimeter Gauntlet. And if your multimeter is great, it'll shine. If your multimeter sucks, then it's going to, I'm going to call it out. I have no choice. They said, oh, let me contact the higher up people about that, the rep. That's what they said. And then like a few days later, they said, okay, yeah, give me your PayPal. We're good for it. We'll send you the multimeter. We'll send you the money you need, order your parts, make the video. And so that's what I did. And lo and behold, the Kaiweets multimeter was surprisingly accurate. I mean, well within its specs all the time. And now that I have the Unity 5.5 digit multimeter, I can even say, because that's a traceably calibrated multimeter, I can even say with confidence that it's well within its specs. So it's pretty awesome how that all fell together. And I was constantly thinking now that I need a 6.5 digit multimeter to try to keep Unity honest on their 5.5, right? So yeah, if you're listening and you have a 6.5 digit multimeter I can borrow, let me know. We'll work something out. But yeah, that's the multimeter thing. And the reason also that I'm talking about this is because I do all this live. So you can go over to SE made a stream. Yeah, whatever. I'll link it in the description below. And you can watch me test my multimeters live. So there's no trickery. I have usually an audience of about 5-6 people. It peaks about 10 people because it is kind of like a secondary channel that I don't have a schedule for and whatever. And you can see everything. I do everything live. In fact, you can go there and check out the VODs. You can watch me work how I did the multimeter review. In fact, if you're not on Patreon, that's a good way to take a look at what I'm doing before the video is released. So yeah, go take a look at that. And the plan is, because I'm feeling better, is that I'm going to tackle a little bit more difficult projects over there, hopefully before winter is up. So there's a couple things that I'm going to talk about today, but one is the sno-speeder build. So I need to get printing a bunch of other parts. I kind of want to put that together before the snow goes away, which here up here in Canada today is the 15th of January. And so I may have a month, I may have 2 months. I definitely don't have 3 months before the snow goes away. But it's not uncommon that the weather just shifts weirdly. So the sno-speeder build, I also have, I want to make an autonomous trolling motor for my fishing in the summer. Now this is going to be a little bit complex. It's not unheard of. It's been done before. But yeah, I want to talk about that. Essentially, I want to mount my trolling motor to the front of my boat and control it from the back with a small RC controller. And eventually, hopefully this year, but maybe next year, I've bought the parts already though. I want to make it autonomous where I can put GPS waypoints and have it just follow the waypoints and, do essentially an autonomous trolling motor build. So that's another thing I'll be working on soon. I also have little things I need to do, like mechanical things, like I have to fix my outboard motor, do maintenance on it. So essentially, if you just want to come and hang out, the SE made a stream that you'll find in the description below. That's a great place to subscribe, put on your notifications because it's a little bit random when I'm going to go live, and come hang out with us. All right, so let's talk about the automated trolling motor project. And let's talk about the problem I'm trying to solve and what sort of electronics I'm going to solve it with and why this makes an interesting project. First and foremost, when you're in a boat traveling at speed, so reasonable speed, maybe 5 to 10 kilometers an hour, 10 kilometers an hour and up, let's just say, your boat tracks straight in the water because of a couple of things. One, the hull design has like fins. I'm going to keep this very top level, but the hull design is made to go in a straight line, so it tracks straight. Also, your motor has a hydrodynamic shape and a fin called a skeg on the bottom. All those things keep you going in a straight line. So going at speed, not a big deal. Where it becomes a problem is when you're going slowly. If you're going very slowly, you have none of those hydrodynamic forces keeping you in a straight line. And especially if you have a lightweight boat like I do, I have a 14-foot all aluminum boat, and it's essentially the bare minimum, just all aluminum. The wind will shift you from side to side. Now, I sit in the back of the boat. This is where I control the trolling motor from, or the gas motor from. And I also have my trolling motor mounted back there, my electric trolling motor, which can only go slow. And I control it by hand while fishing. Now, the goal of a trolling motor, there's two things. One is to go a little bit slower while you drag your lure in the water. And that means that, like, think of a regular retrieve. Your lure is doing that constant speed over a large area, right? You just use it to just drag your lure around a set path that you're controlling. The other thing you can use a trolling motor for is to go very slowly around structure and cast your lure with your fishing rod, around that structure. And every cast, in principle, since you're moving, will be in a section of water that you haven't tried casting on yet, which means if fish aren't where your first cast is, maybe it'll be on your second or third, et cetera, et cetera. So the issue becomes that I have to, with the trolling motor in the back with me, I have to constantly compensate for any sort of current or wind that turns the boat. It deviates the boat from my predetermined route because I don't have any of those hydrodynamic forces acting upon the boat like when it goes fast. So it's much harder going slowly to keep the boat in a correct heading. So a good solution to that, though, is that instead of having the trolling motor push the boat, you can have it pull the boat. So you can mount it on the front of the boat in the bow. And that means that then the boat is a lot more stable because if the back end swings a little bit, it's less exaggerated than if the front end swings. The problem with mounting it in the front of the boat, though, is that now the trolling motor is about 12 feet away from me. So I'd have to go, transfer myself from the back of the boat to the front of the boat to go control it. When I go fishing with my old man, which is what I've been having a lot of bonding time with him. We've been going fishing in the summers together. He sits in the front, and I want him to concentrate on fishing and not on directing us. Plus, he doesn't have the same interest that I have in figuring out where the boat should be going, like where the fish would be hiding, et cetera, et cetera. So here's the short-term goal. I'm going to build a mount to mount the motor in the front, but then I want to be able to control it from the back. And so I'm going to 3D print a gear system, and it will be able to go it'll be able to, when you take the trolling motor from its stored position to its active position, it'll mesh a gear into the base, and then all these things can be 3D printed. I have a large servo, 100 and some kilo servo, and it'll be able to turn the fishing, the trolling motor wherever I point it, using a little remote control that I can wear on my neck or on my hip or mount to the boat or whatever. The added benefit this gives me is I can also, because it's just a DC motor, I can control the speed. We have tons of modules that are, motor speed controllers that should be able to handle the current. I think it's about 30 amps of current at full tilt on that trolling motor. And that means that I'll be able to also have infinitely variable throttle. My trolling motor only has 5 positions or 4 positions of forward, and then 5 positions or 4 positions of reverse. And I find that when there's no wind, when it's calm, the first position goes too fast. So I'll be able to just have the boat go from a complete crawl, or maybe even just fight the current enough to keep us stationary, all the way to full speed. That's an advantage. Plus, I'll be able to control it from the back of the boat. So that's pretty great. They do make trolling motors like that. They do make them already like that. So they have a specific mount, and you essentially mount it to the boat, and you have either a pedal, like a foot pedal, that you can control the direction, and then you have a little wheel on the pedal that you can control the speed. That's good. You even have some which are a bit fancier. They have a remote, so you can do it all like what I'm talking about, remotely with an electronic remote. However, that's like $1,000. I paid just about $150 like 10 years ago for my trolling motor. And if my trolling motor dies, like let's say it corrodes or whatever, I don't want to have to throw away the whole thing. I want to be able to just get any trolling motor and replace mine with it, and my electronics will continue working. Now, the additional benefit of all this is that once I am ready, like this is just like stage 1, which should be fairly easy. A few people have done these types of projects before, so I won't be all alone. I should be able to follow other people's, projects as guides and whatever. Now, to make it even better, once you have the remote control of it, then all you need to do is add a module with a GPS, and now you have a GPS-controlled trolling motor. You can literally open a laptop, go to the satellite image of your lake or river or whatever, and set waypoints on it. You can literally draw out waypoints and then send them to the module. And then when you activate it with your remote, it'll go to the first waypoint, hit the speed and heading that you want, and do the trajectory. Finishes the trajectory, it can go back to the first one, it can go to the next thing. It can do all of this autonomously. And when you have the control with you, you can then override it. If like the wind is faster than what you expected, you can tell it, okay, do the same thing, but go faster. You can also set the precision. Like if it doesn't matter what ballpark, like if you can cast 100 yards, it's pretty far, then you can just tell it, yeah, go to this waypoint, but like within 10 feet or something, or within 30 feet. Or you can be very precise, like I want it within 3 feet, right? If it's something really important to navigate through. So all this can be done. And I have ordered the parts for this specifically. Now, I want to say that this didn't come from my own imagination. There is a YouTube channel which I love very much, RC Test Flight, Daniel Riley over there. He's been using these modules, which I bought one specific one. I don't know which one he uses, but I think he's using the same one as me, at least for some of his projects. But essentially, he's made autonomous boats, like scale boats. Like one of them is like a big Tupperware container. He's designed like pontoon boats. He's even attached it to his own like manned boat where he was sitting in the boat and it was driving him around. So I do know this is all possible. But he's also attached the same system to remote control planes, to remote control rovers, to all sorts of things. So I'll link his channel down below just so you can see the potential here. But essentially, I chose to go with the Pixhawk PX4. I just want to make sure that's actually what I got here. Yes, so the Pixhawk PX4 Pro. And essentially, it's a 32-bit ARM Cortex M4, and it uses all sorts of sensors like an accelerometer, gyroscope, magnetometer, barometer, all sorts of things like that to do the autonomous control. And it runs on, I believe it's open source software. Now, I'm just like dipping my toes into this, so I'm not quite the expert yet, which is what I like the live streams for. It allows me to, discover along with you guys. But it's, I believe it's open source software called Ardu Rover or Ardu Pilot, which is meant to be used in these sort of like modules in order to do all of the heavy lifting of the controlling of things like your rovers and whatever. I believe you're not supposed to use it in manned vehicles. You're supposed to say, it's only for unmanned vehicles, but I think if I have override control around my neck or whatever, I'll be okay. But essentially, you get this unit, and then you got a whole lot of things that attach to it. So you've got like a current sensor, so we can check the current used by the trolling motor at all times. There's a GPS, which is really important. So it's got a big, like a GPS antenna and a mount for it. You get a airspeed sensor. You have radio transmitters and receivers for all the telemetry data, like where the boat is currently, like what kind of route it's doing, your battery voltage, stuff like that. And essentially, this one unit is just a unit. It just does the autonomous things. You can configure it in all sorts of ways for all sorts of devices and vehicles. And so that means that I can use this for the boat, but also I can take it out and put it on, for example, the sno-speeder. I can design a rover and use it for that. So it's a little bit expensive. So I paid, hang on, let me get the price here. I paid about $300 Canadian. Yeah, about $300 Canadian for the whole shebang. But I believe it's going to be worth it because it comes with all sorts of accessories. It should be everything I need, and I'll be able to use it in more than one project. I find it interesting though, because it's made for remote control vehicles. The connectors that come on the current shunt, they're just XT60s, right? They're just tiny little RC connectors, but they should be powerful enough. They should be strong enough to deal with the voltages in my trolling motor, because the current used by my trolling motor. Now, I'm not 100% sure. I'm going to switch to my secondary YouTube channel, because on there, I actually... Oh, what? Can I change? And then go studio. Because on my secondary, which is SE Con Dairy, like dairy, dairy, like literally milk stuff, I have a video. I actually went and tested... I'm going to make sure this doesn't make any noise here. I'm going to mute the site, where I tested the current. So I actually know how much current my motor draws at full speed. So yeah, at full speed, 27.4 amps of current. So I think I'll be perfectly fine using off-the-shelf motor drivers and off-the-shelf components like remote control stuff, and either design my own remote control using an NRF, NRF 24L01, which has defeated me before, but who knows, maybe this year is my year, and a big servo. And that servo will be able to mesh with the gears, and it will be able to spin my motor. So I'm pretty excited to see what comes of this, but this is not something that I will be able to do in an afternoon. It'll take a lot of time, a lot of trial and error, and this is what the live streams are for. The live streams are for discovery, and so if you want to come and discover with me, then yeah, that's where it's going to be. It's going to be on the live stream channel. The other thing I think is really cool is if I use all off-the-shelf components, then that means that people who want a GPS-controlled trolling motor, which they do sell, by the way, they're worth more or less like $1,500 to $3,000 and more. They should all be able to make this attachment for under $500. less than $500. So they'll be able to keep the trolling motor and stuff that they already use, already own, and just add the electronics to it. And the other thing that's really cool is that if someone just can't afford the $500, they can still go remote control, and that part is going to be very inexpensive. To go remote control, it's going to be under $100. It's just the GPS stuff and whatever that might cost a little bit more. So obviously everything I design is going to be open sourced, and people will be able to download the files and get them printed at their local library or wherever. And then, they can add this to their own boats. And it's not just for fishermen. There are a lot of people that just want to be in the water. They just want to be, they just want to go for a ride in a boat. And a trolling motor is a great way to do that because it's very low speed. So you don't need to be competent. You can go into waters that you're not really familiar with, and you won't knock a giant hole in your boat if you hit a rock at the speed that a trolling motor goes. So it's just a nice way for people to have access to the water for very inexpensive as compared to, the whole gas motor situation, which is quite expensive these days. So I'm pretty excited about that. I think it has wider uses than just, fishermen. I think it's really cool to be able to just lounge and control the boat with a little remote control. And if everything goes bad, you can always take manual control back from it. And I can't wait to put that into effect. Hopefully, I'll get this done, at least the remote control part, before the fishing season opens, which usually is about mid-May. So now on to the sno-speeder. This is, the more time-sensitive one, I suppose. But there's a couple things that have been stopping me from getting into it. So first things first, why do I want to make the sno-speeder? Well, I believe, it represents the fact that a project is completely done, right? It's the first sno-speeder V1, which is now in bits essentially, represented the first thing I fully designed and 3D printed myself, all in Fusion 360. Everything was 3D printed, put together. I did it all, and then I went out, I made a video, and the video was one of the first things I did a complete, high effort thing on. I literally had to go out a couple times, get a whole bunch of footage. I edited it all together, found, music that worked, made a little sketch at the front. It was essentially the highest effort post that I had made. So V2 though, might be a little too ambitious, and I'll tell you why. So first things first, I made a ginormous frame for this thing. So the original sno-speeder, I believe, had a 6-inch prop. The current sno-speeder, the version, whatever that we're on, version 2, I believe it's either a 10 or a 12-inch propeller. I bought carbon fiber propellers for it. The motor is 2 kilowatts or something like that, maybe 1800 watts. It's getting a little fuzzy because it's been a long time since I've worked on it. And I believe that my first big sort of hang up with it is that I think I made a mistake in the chassis design. And the chassis is a massive part that took, 30 hours to print or something like that. So the problem is I have a lot of space inside the chassis for my electronics, but there's no way to access them. It's kind of like a hollow body. You'll see when I make the video eventually. But it's kind of like a hollow body. And so the electronics will have to slide in. And if they slide in from one of the ends, they'll have to slide in quite far. This thing is, over, it's over a foot tall because it's almost maxed out the 3D printing volume of the Elegoo Neptune 4 Max that was sent. So they'll have to slide in, and then it'll be very hard to fasten it down. And once it is fastened down, then it's not super accessible. And so I am debating redesigning and reprinting that part, but that is a lot of filament. I think it's just under a kilogram, a full spool of filament just for the body. And that's with just, double walls, and the rest is like 20% infill. It's just a lot of material. And so, yeah, I kind of regret designing the piece so big. But the idea was that the first sno-speeder was made small enough that even though I had a build plate on my really shitty 3D printer of 220 by 220 by, it was pretty tall. I think I had 300 tall. I decided to limit myself to 200 by 200 to make sure that pretty much anybody who wanted to make the project could have the build volume necessary to make the project. The issue is, I don't think anybody 3D printed their own. I don't think anybody made their own version of the sno-speeder. So I kind of like limited myself to the design constraints for no reason. Whereas for V2, I thought, well, I want more speed. I want more power. I want something impactful. I want to make a really good YouTube video. And so I went really ambitious and made a gigantic frame. So regretting it a little bit. I wish I had a hatch on the top that I can access the electronics from, but it is what it is. Like, I don't think I want to reprint another 30-hour print. So I don't know if I'll end up cutting it and, making access hatches, but it sounds like more likely I'm just going to make it work. I mean, it just has to work long enough for the YouTube video, although I would like this thing to be fun and be able to mess around with it, otherwise, but it is what it is. So that's the first thing. The second thing is that I have to design the front suspension. So it's going to be very complicated. I used new construction techniques in Fusion 360, whereas I took the design, I stretched it out a certain distance, and then I shrunk it, and then I lofted. I made I essentially made the old design, the design that was slightly lower, come up and join with the top design. And that's kind of like, then I went up and then did that again, then up, then did that again. And I got to a point where the geometry was, it was as tall as I could make it without, or else it wouldn't fit on the Neptune 4 Max. And then I had to stop it there. And then I put holes so I can put, the heat set inserts. And now I have to start from there and design a front end. And that's a bit daunting because this is no longer just like a body. It has to be mechanical. It has to actually work. Now I have the design for the first sno-speeder, which I can probably integrate the design into here, but it's a lot of work. It's really difficult to get the geometry right. And also when you're 3D printing, you have to design you have to make your designs work for that layer by layer sort of buildup. So, I can make cutouts and stuff. I first of all, I have to make some nice geometry that'll follow the lines of the sno-speeder the way the body is already. But also I need to make cutouts to hold the servo. I need to have some way to have the front pivot, like steering pivot and stuff like that. So it becomes a very difficult design challenge. And I am an iterative designer. I sort of like try things and then measure off them and then, make design changes and then print again and then measure off them. So that takes a very long time. And I understand that because I haven't done it for a while, like because it's taken the back burner for a while, that means it's even harder now because I need to get back into it and remember the design constraints that I had before. So I guess what I'm saying is the project became so large that it is now daunting just to hop into it and try to make it work again, right? So that's kind of the thing that's been setting me back. And the live streams do help with that because I could just figure, as long as I'm working on it, as long as I'm getting stuff done, it's all valid. But yeah, it's a bit scary to dump. I probably have about 35 hours in designing the body already, and now I have to design pieces that will attach to it. And I guess if you're picturing this, like the body, the fan section sits flat on the build surface, and then the body stretches upwards from there. And then there's holes where I'm going to put the heatset inserts, so that's fine. But on the receiving end, on the part that it's going to bolt into there, I need to put recesses to like bolt holes to be able to put bolts through it. So I've got that to contend with. Plus I've got to cut a servo hole out, which probably means I'm going to need to use supports, which are very difficult to clean off. And then I still have to get the geometry right for the steering. And so, yeah, it's not simple. It gets very complicated, and I kind of painted myself into a corner. So I want to do it. I will do it. But, I have this nagging feeling deep inside that I'm going to spend, 100 hours on designing this thing and then putting it together and then going out for a rip. And then it's going to get like a couple of views on YouTube. So, I mean, I don't do things really necessarily for the views. I do them because I want to do them. But at the same time, when you spend hundreds of hours on something and then you end up, making $1.50 off the couple hundred views you got, it's a little bit discouraging, right? So if I'm looking at the sno-speeder, the version 1, let's check how many views it has. Probably not very many. 7.9K. It made me $9.84. And that's just because it's my sort of intro video. When you go onto my channel, it auto plays. So yeah, I'm pretty excited to do the sno-speeder build, but I'm going to be more excited when it's off my plate because it's something I've always wanted to do, but I'm going to be happy when it's done. Also, I haven't picked the second color, so it's a red body because I thought the red would look really good with the black motor and the carbon fiber propeller. But the suspension, I think, should be a different color. And the skis probably red again, but I don't know what that second color should be, because if it's black, if the whole suspension is black, then that's not great for the thumbnail. The thing is very big and kind of bulky, like wide, but like wiry too, like the arms are thin and stuff like that. So it doesn't look great on thumbnails. I worked really hard to get a thumbnail for my previous one, and I'm really not happy with how it turned out, but at least I got one done. So this one, red and black looks amazing, but I'm not sure how I'm going to make that look on the thumbnail. And the thumbnail is like the most important part of making your video if you want it to be seen. So yeah, that's going to be a little tough, but I guess it's a challenge I'm willing to take on. The suspension parts, they can be reused. I've designed the body to reuse the suspension parts from the version 1 sno-speeder. So they are mostly printed in black already. But if you have a different idea, a different color idea for me, let me know in the comments, because what would go well with red but isn't black, that, so it doesn't disappear for the thumbnail? Essentially. And I'm willing to hear out any options. I was thinking purple because it's the channel color, but red and purple kind of clash, so it's not great. But yeah, I'm willing to hear your suggestions. What color do you think it should be? Red and what? All right, at this point, I've had to pause so much for coughing that I'm just going to have to wrap this up pretty soon. So not too much left of the podcast. Just going to do a little bit of a personal update. First and foremost, BitLooney, if you're listening, this one's for you. The transmission saga is over. So for those of you that don't know, I had a Volvo V70 and I poured probably like 40 hours of my time and a couple $1,000 trying to get the transmission fixed when the transmission blew up. I bought a used transmission. When I went to replace that transmission, an axle broke, the starter broke, a whole bunch of stuff broke. The fluids needed for these transmissions is very expensive and they're very picky. So I had to special order some from the States, put the used transmission in, and it lasted all of like under 100K, probably like 40 or 50 kilometers. So I had to take the transmission out again. By the way, I don't have a lift at home. This was all done in my driveway. And the second, it was pretty hot the time that I had changed it. The second time I had to pull it out, it was 40 degrees Celsius. It was horrible. So anyways, took it out, brought it back to the auto recycler. He gave me another one. I put that one in and it lasted like 15 kilometers. So I was at that point just done with it. And I ended up buying parts to try to rebuild my transmission. And the plan was to rebuild it this winter, have it up on a stand. But it never happened. I ended up buying another used Volvo, this one with a manual transmission. That's the one I'm driving now. And with the snow coming, I don't have any space to park an extra car. Can't park on the street here in Ottawa when it snows because they do snow removal. You get tickets and then you get towed. So essentially, since I don't have space, I decided to donate it to a high school for the students to learn on it. I gave them the transmission, the second used transmission that's installed in there. I gave them the original transmission and I gave them the new parts that I got. And I told the auto shop teacher, if you take apart my original transmission, I believe that the valve body is the most likely culprit. So here's the valve body. This is from a GM of similar vintage. You'll have to change the solenoid, over with the old one. But if you put that together with this fancy transmission fluid that I ordered in bulk, it should work. So whatever they decide to do with it is up to them now. But essentially, yeah, I donated everything. I should get like a tax receipt for my donation, but I don't know, things happen at a glacial pace, so it may not be on time for this year's tax season. It is what it is. It's gone. So the car literally cost me a couple $1,000 plus, the purchase price of the car a couple of years prior, plus all the parts I had put into it and all the spare parts I have for it. So it's just a complete loss. I have my current Volvo. It's a V50 now. And the problem with this Volvo is that it's very uncomfortable. The seating position, the way the seats work, and everything is not good for my back. When I drove to my in-laws this Christmas season, I don't want to say how far away it was, but very, very far away. Basically a day of travel. It hurt my back. Usually the hour-long trips sometimes I have to go to work with hurts my back. But this was exceedingly bad. Plus at my in-laws, their bed is not, it's not my bed at home. So in a new bed, my back was a little bit iffy again. And then all those hours driving back. And then when we got home, we had to shovel the snow. Essentially, my back has been destroyed since. So I also caught a cold. I caught, obviously with the last podcast and this one, you guys can hear it, but I caught a cold or something from my in-laws. So I haven't even been back to work. I'm supposed to go back to work tomorrow. That'll be Thursday the 16th. And my back is in not great shape. And I'm just still, I still have a cough, although I don't feel sick anymore. So new from all of this traveling and sitting in my uncomfortable Volvo, I have now sciatica, I believe. It's like, I don't know. The best way I can explain it is that when I'm standing upright, I feel like there's like a tight cord, a tight rope from my lower back all the way down to my right calf, essentially. And if I lean over a little bit, it gets very, very tight. I'm doing quick research. Apparently, it's a pinched sciatic nerve, which is not good. So, yeah, the point is I need to get rid of this Volvo. So in spring, when I have more time to inspect cars, because, here in Ottawa, you don't want to buy a rusted heap of junk. So you always got to check underneath. And there's snow everywhere. So I don't want to crawl in the dirty snow underneath the cars. So essentially in spring, I'll be looking to replace this Volvo as well. Just add it to my pile of stuff to do. On good news though, I just got a contract for the next 2 to 3 weeks. They don't know, for the college to replace a professor. He's fine, but he's out for a couple of weeks. And so the deal with that is, because that professor is a full-time professor who I'm replacing, I have to replace his full-time hours. So it's more hours than I typically do on a on a contract basis, but it is for less time. I typically do 8-week contracts. This one's 3, but it's more hours. So yeah, we'll see how that goes. The point is, more work is more better, especially the teaching work, because it's not as physical. It's much more mentally draining, which is totally fine. As far as I know, I'm not bleeding from my brain, so I can keep using it, but it's my back that's not great. So the mechanic work may suffer this year, but it is what it is. You got to do what you got to do. On that note, I am looking for your help, listeners. If you know of a cool or novel circuit, now I'll give you an example. The 555 timer PWM circuit that I put together a bunch of years back, that kind of circuit, a circuit that's very interesting to look into, that does interesting things, but is relatively simple and made out of relatively simple parts. I am looking for those. Now, I don't really want to go onto, into Forrest Mims' books and just do, all of his circuits. That's not quite what I'm looking for. I'm not looking for something that, has a specific origin of design. I'm just talking about cool circuits that use relatively simple parts. One thing I can give you as an example, aside from the 555 timer PWM thing, is like a voltage multiplier. That's one thing I want to play with. So I'm going to be looking for all sorts of these cool circuits. If you want to put them down in the description. I also have a form. If you go on my live stream channel with a video ideas form, I believe it's a video ideas form. Anyways, you can click there and type that stuff out. You can also email me at dan@simpleelectronics.ca. That works as well. And there's also a contact me form on my website, simpleelectronics.ca/contact. So yeah, reach out. And if you got really cool circuit ideas, let me know. I'm going to be looking for them. I'm really interested in understanding how they work. And I'm going to probably make a video, showing how they work. I think it would be really interesting. So we've got that going for us, which is nice. Also, it's an opportunity to have fun on the live stream because I get to build these circuits up on breadboard and see how well they work. And of course, the same rules apply if you know of anybody interesting that you would like to see on the podcast. If you know them, or if you yourself have some interesting things to show off, reach out if you want to be a guest on the podcast. I'll give you a good example of some of the out-of-the-box stuff. I reached out to a space company, a very small company who was sending stuff into low Earth orbit. So I reached out to them to see if they want to chat on the podcast. I'm not going to name them, obviously, because in case they don't want to come on, I don't want them to be pressured or anything. But I'm looking for really cool, interesting people with interesting projects. Just looking at the front page of Hackaday, for example, will give you a ton of ideas of the types of makers I want on here. Basically, anybody with, anybody with a cool design and a cool perspective on making, I want them on the podcast. So if you know them, have them reach out to me. If you just have a suggestion who I should reach out to, you could do that as well. But it's very difficult for me to reach out to people. Makers are busy and they typically get bombarded by emails all the time. So often they don't answer their emails. And I think that's even worse when we're talking about women makers or non-binary or whatever, because the internet is not a safe place for them. So non-men essentially tend to not check their DMs because their DMs are typically a horror show. So yeah, if you have ins with, people who are hard to reach, let me know and, hook me up with an interesting guest. So I hope to catch you in the next one. Hopefully my next podcast won't have lots of cough edits and they won't be so hoarse. And I will catch you in the next one. Thanks for listening, everyone.